Yeah, it started.
Yeah. So hi, I am Richa Garg, and I will present about the big data. So as my first talk in this group was about the DBMS, that is database management system. So we have talked about that how we have been moved from that pen paper system to file system. Then we moved to file system, from file system to database management system. Then we have talked about that uh, how we have moved from database management system to big data. So we have talked a little bit about big data, like the introduction and the need of big data. So today we will discuss about like uh, more about the big data. So I'm going to present about the uh, big data. So first of all, we will do you have any idea about big data? What is big data? Why we are calling it big?
No, ma'am, I have no idea.
So as the name suggests, big data, it means the size is big. Only this thing. Big means the size is big. It is a huge data. So if we want to know what is a big data, so we can take a simple example of mm, 1 minute. There's some problem. There's some problem in slide movement.
It's not going to the next slide.
Yes, yeah. Now it's working.
Now it's gone.
So so if we talk about the mobile phone, so everyone is using mobile phone these days. So do you have any idea like how the mobile phone is generating data? So can you imagine like how the mobile phone is generating data? How we are through which mediums we are generating data through mobile phones?
Means we are clicking pictures, saving contacts, doing messages. There is a lot of cache files are there which is being saved.
Yes, correct. So in the form of phone calls, in the form of text messages,
Yes.
clicking pictures, taking videos, they are generating data, sending emails, searching on the phone. So all these things are generating the mobile phone, the mobile data. So if we talk about the data, so the data which is being generated by the mobile phone by a single user, can you imagine how much is it? It is a 40 exabytes of the data per month, single user on an average. So 1 exabyte is like 10 to power 18 bytes. So we are generating 40 exabytes of data through our mobile every month, and it is for a single user only. So if we say that 5 billion people are using mobile phones, so how much data we are generating through mobile phones in a month? It is like 5 billions into 40 exabytes. So this is a figure. This is the data we are generating through mobile phone every month. So this is a very large amount of data. It is not a small data. So this uh, this data normally in our normal system, and if we talk about the normal database, the traditional databases which we are using for a system, for example, if we talk about the university, there is a database in the university itself, and there is a server in the university, and we are having the data of a student, of the teachers, libraries, attendance. So this is a traditional database system. It is not a so big data. So if we want to handle this amount of data through that university database system, which we called as DBMS or RDBMS, that is Relational Database Management System, which is being used in like shopping malls and universities or the normal systems. So these database cannot handle this high amount of that data. So it is not it cannot be handled with the traditional database system. Similarly, if we talk about the internet, so we all use Facebook, YouTube, Google, Snapchat. So Can you imagine how much data we are generating through Facebook, YouTube, Google? So any idea like how many people log in the Facebook per minute? You can tell me. You can any guess?
Maybe hundred or millions. I don't know.
Yeah. So per minute, 1 million people log in the Facebook. And the YouTube, we watch the videos on the YouTube. So per minute, 4.5 million videos are watched in the YouTube. These are the stats. So in the Google, 3.5 million search queries per minute we are searching on the Google. And in the Snapchat, 2.1 million snaps are being shared per minute. So all these millions of the data is being generated in per minute. So we can like we even can't imagine how much data is being generated by these big applications or big softwares like Facebook, Google, YouTube, Snapchat. So this kind of data cannot be handled by this um, traditional database system. So here the need of big data arises, like the some other system which can handle the high amount of data. So we need some other method of storage, method of processing, other method of analyzing the data, so that it can be stored correctly, processed correctly. So now the question comes, when we classify the data as a big, because we don't have any discrete definition about big data. Generally we can say if our system can't handle any data, it is a big data. If you are having a hard disk and your hard disk can't handle some data, so it is a big data for your system. If some other system, some university system cannot handle some amount of data, that data is big data for that. So there is not any specific definition, like if some data is beyond this limit, then it is big data. It is not like that. We can classify by some factors, like how we have to handle that. So we can say that we use uh, s- 5 V's for classify the data as a big data. So first is like value, how the value has been added by this data. Second is veracity. Third is variety. Fourth is volume. And fifth is velocity. So these 5 V's are there, by which we can try to classify the data as a big data. So what are these V's? So first we talk about the volume. So big data is basically based about the volume. So if we talk about the healthcare industry, for we will take the example of healthcare industry. So healthcare industry. So which type of data will health care industry store? Like if you imagine like which kind of data will be stored in healthcare industry database. So uh, any guess or any idea?
No, for hospital, I have no idea how much data are they producing.
In general, like if we go to hospitals, like the patient records are there, this is the data. Test reports are there, this is the data. Healthcare workers records are there, this is the data. Medicines are the data. So all these are the data here. So these days, the number of patients, the number of tests generated by test results, and then the treatments, all this data is generating very fast. So as per the report, the healthcare industry is generating 2,314 exabyte data per year. So this is a very big amount of data which is generated by health industries. So we can classify that data as a big data. It can be a candidate of a big data because normal database cannot handle these kind of volume. Then it comes for velocity. Velocity means how the data is growing, like what is the speed of the data. So we can say healthcare industries data is growing very, very fast, exponentially, because the patients are coming, the test, the more are the number of tests and test reports are getting. These are the frequency of these things are very high compared to the previous time. And also the developments, new medicines, new treatments. So all things are like getting very fast. So healthcare industry data is very growing very exponentially. So if the data they are creating data 2314 exabyte per year, so their data will grow very with a very high speed. So the growing speed of the data is very high. So we can understand it more by the taking an example of a traditional database system. So if we will talk about the university's data, so we will have the data of a student, teacher, attendance, library, this kind of data we will have. So how will that data increase? What thing will increase the data? So can you tell me like how the data will increase in that? How will the then which type of data will be added on that?
Means you are asking about linearly or exponentially like that,
No, no,
or
normally,
in
normally
which
like
form it will include?
think when the data will be increased. For example, like if the new student will come, then only the data will be increased.
Okay, okay.
Apart from that, like if attendance data, that will increase
Attendance data
regularly.
or examination time, the data will
Examination
increase.
data or the teachers
Means
addition and like if teacher is leaving, this kind of data is only adding or subtracting from the database.
yes,
I think it is the only data university is having.
yes, yes, yes.
So this data cannot grow very rapidly because there is not anything which is happening regular basis. Only
Every day,
apart from that attendance part, and attendance is also a very short data,
very short, very small data.
a small data. So we can understand like compare the data, like how the university's data is growing and how that healthcare industry's data is growing. So it is very different. I'm talking about the whole or like some chain of some hospital, like all the healthcare industry. So it is a big data. So if we will talk, if we will merge the data of all the universities in a single place, then it will be a big data. But if we will talk for a single university, it will not. It will be a small, like traditional data. So the whole data, if we are putting for a healthcare industry, it is growing very exponentially. So variety of the data also important. So variety, what is the variety of data? Structured, semi-structured, and unstructured data are there. So what is structured data? Structured data are when we have the data in a proper format, like we are having rows and columns. So in Excel file, we can see there are rows, there are columns. In the table also, there are rows and there are columns. So it is a structured data. So we are having, if we are having structured data as well as semi-structured data. So what is semi-structured data? It doesn't have any rows and columns, but it is not very unstructured. There are text. For example, we can see the log files. These are semi-structured data. And what is unstructured data? It is like images. So in health industry, we can say X-ray. X-rays are unstructured data. And videos, these are the unstructured data. So if we are having structured, semi-structured, and unstructured data, then it can be handled only by big data. We are not having images and videos in our traditional data system in general, or we can say not on a very large scale. We are having generally on structured data on our traditional database system, which is in table format. There are rows and columns, and we process the data in the tables only. So if we are having different varieties of data, then it is a big data. Then veracity. What is veracity? So it is like accuracy. So the big data should be very accurate. It means it means if we are in the healthcare industry, if we are searching for a test report of some person X, if we are not getting the report of X and we are getting the report of Y, you can imagine how disastrous it can be. So doctor is giving treatment to X person for a disease which is not which is not having by X, like the report by seeing the report of Y, they are giving the treatment to X. So how like problematic it can be. So the accuracy should be 100, must be 100%. So that is the necessity for the big data. and it should be trustworthy. The trustworthiness is also very important. So like if we are getting the data from some big data, it must be trustworthy. Like data is correct and we can produce some result on the data, and it will be trustworthy. Otherwise it can produce very like bad results, or it can create disasters. So the trustworthiness and accuracy is also very important in a big data. Next, we talk about value. So how the value is being added by the big data. So if we talk about that health industry, so how the value will be added if we are having this much this amount of data, like the disease detection will be easy and fast. If we are having very much data, we are having data across the from the globe, so we are having like many cases in the our database, like the symptoms, how the disease was detected to some other person. So it is easy to detect the disease when we are having so much of data. After that, we can say that it will add the value of better treatment. If we are having a data in which we are already having, like in for some specific disease, this type of treatment was given to this patient, and these are the effect of this treatment, or these were the side effect of this treatment. So we can go for the better treatment if we are having much data about that, like how some medicine was reacted on some disease. All the data we are having, it will go for better treatment. Then we can say that it will reduce the efforts mean if we want to know the availability of some medicine, if we want to know more about the disease which we don't have much idea about in previous. So if there is someone else has faced that problems, we can have in our database, and then we can easily access that, and we can reduce the effort. We don't need to go anywhere, we don't need to consult many people. If, in earlier days, the medicine availability was a very big task. Like if we don't we need some specific type of medicine for some specific disease, it was a very big task to find out that medicine and take that medicine. So now it is very easy that where it is available. So it reduce the efforts. And then if it is reducing the efforts, it reduces the cost, because we are having like we can easily access the resources. So the all over the cost reduces. So in like by these examples, we can say that big data is adding value in some business on and like in some process. So then it is can be classified as a big data. So yeah, it is clear, Nikhil, or any doubt?
Yeah, it's clear, man.
Okay, so now we will talk about, like it is all about the big data, how we will classify the data as a big. Now, if we are having big data, how we store and process that big data. So we are having frameworks to store big data. So framework, for example, if you have heard about Hadoop, Apache Spark, Cassandra, these are the frameworks we use to store and process the big data. So there are many companies who provide these frameworks. For example, Google, Amazon, and Microsoft. So Google provides Cloud Platform, GCP. That is this is the name of the services which Google provide. So in these services, Google provide Hadoop, Spark, and the services from Amazon we called is AWS. If you have heard about that, Amazon Web
Yeah,
Services.
I have heard. AWS, I have heard.
Yes. So it is also very common these days. So the AWS provide these all the big data services. Same with Microsoft Azure. So these are the technologies which we are using to storing and processing the data. So we can take example of Hadoop, how Hadoop work to store and process the data. So Hadoop uses the distributed file system. So what is distributed file system? So if we are having some 900 MB file, so in our traditional database system, we store the 900 MB file in our database directly. But in Hadoop, we are having a big amount of data, so we cannot store this data uh, in a single server or in a single chunk. So we divide this file in three parts. Each part is of 300 MB. So the 900 MB file has been divided into three small files. Now we will store these 300 MB files in the different servers. So in big data, we don't have a server centralized or placed at a one place. The server is placed at multiple locations. Like we can say one server is available in Australia, one server is available in Europe, one is available in India, one is available in Russia. So there are multiple locations across the globe. They keep the servers in different locations, and they distribute the data across the locations. For example, AWS means Amazon have 26 geographic locations where they have placed multiple servers. Same way, we can say that Facebook is having more than 80,000 server across the globe. So they place the server on a different places, and they place the data in the different servers. So we uh, we divided this file in three files, three sub files we can say, and then we place these files in different servers. So here we can say we can see there are three servers I have presented. So first server is having a yellow file like this one. Second is having green, and third one is having red. But with these three files, I have copied this red file in first server, also green file in second, and that green two times green, and two in on the two servers yellow, and on the two servers red. So can you tell me the reason why we are having two copies on each chunk of the file?
Maybe to retrieve, if somehow we missed one file, we can get it from the another server.
Yes, correct. So sometimes it happens that some server crashes, the system crashes. So if the second we can say like if server 2 crashes, so we will lose the green file. So we are having the copy of green here. In the same way, we are having copying of yellow here. So if some server crashes, we can get the file from a different server. So it was just a small example. They have multiple copies on the multiple locations, and they don't have the whole data whole data, the whole file on a single server. They have chunks of the file. So how it adds the value on the processing. Like Hadoop use MapReduce technique. So what is MapReduce technique? If we have to perform some task A on the database, so it will divide this task into three tasks: task one, task two, and task three. And now these three tasks will be processed on the different servers across the globe, and it will be called as parallel processing. Like not the one task will be performed on the one server. The one task will be performed in the three servers. So if I need to I need to prepare a report, like the medicines and the effects and side effects for the cancer patients which have been given in last 1 month. Like if someone wants to get the latest report of the cancer patient and what the treatments they have got, the updated technology, and what the side effects. So if someone wants this type of report, so we are having like some thousands of exabytes of data. So we will query the data, like I want cancer patient on this big data, and then I want the later last 1 month record of these cancer patient, the medicines and their results. So it is next to impossible if we that one task will one query will be executed on the exabytes of the data. We will not get any result in months of the time also. So what it does, like it divides this task into multiple servers. So if we are having data Like if we are having 1,000 servers and we are having 1 TB of data in on each server, so every server is having 1 TB data. So this query will run parallelly on each server and it will query only on 1 TB data. Every query is working on only 1 TB data and parallelly all the 1 TB data are being queried. So we will get the data very faster and very accurate. So we will get the report in a fast manner because the tasks are divided on the multiple servers. So how this is a technique which Hadoop use. Basically, it is a parallel processing. So did you like understand that?
Yes, as I understand, like it's because of parallel processing, the processing is fast.
Yes. So we have the chunks of data on the different servers, and because we don't have the all the data on a one server. Like if in the previous slide we have seen that the file was 900 MB. So if we will query on the 900 MB file, it may take much time. But if we will query on the 300 MB file, it will we will get the data faster. And
Yes.
parallelly, we are querying the different 300 MBs. So how it works? So after like storing and processing, there's a need of analyze the data. Data analysis is the main task. So that it can give the results and it can add the value of our values on our system, and it can faster our process, and the business can get benefited from that big data. So data analysis is very important. So how it is important, how it is done. For example, you must have played these type of games like Age of Empire. You must be heard about the games.
Yes, I have. I haven't played, but I have.
Okay, so in these games there are multiple stages. So user can pause on these stages. The user can restart. User can quit on these stages. So there can be a like there may be case like some stage is very difficult. So and it is very difficult to move to next stage. So they are quitting, like they are trying multiple times, but they don't. They are not able to reach to next level. So they are quitting the game and they are trying some other game. So basically, what is happening? The business of the game is losing. They are losing their customer.
Yes.
So what they do, they store all the data of pause, restart, quit, at what stage the user has paused, at what stage user has restarted, at what stage a user has quitted. They have all these data and they analyze this data. And after the analyzing, they can find out then that why and when the user is quitting or they are pausing. They can find out that, and after that, programmer can rework on the game design so that they can retain their customer. So it reduces customers churn rate. So customers churn rate means if someone is leaving, some customer is leaving some business, it is customers churn rate. So every business want to reduce that. They want to retain their customer. So it is this technique, this big data analysis help the customers, help the business to retain their customer. And apart from that, like it is very useful in every field. So if we can talk about disaster management also. I've not prepared the slide for that, but the big data is very useful for disaster management. For example, hurricane or that tsunami, earthquake. So it is if we are having data across the globe and data from previous years, we can easily predict the hurricane and that earthquake, tsunami, all the things. And it is happening these days very in very accurate manner that we are predicting these things by using big data. And also apart from predicting, we can analyze that how to um, mm, how to prepare for that, like what preparation are needed for these areas and these areas, what will be the areas and how much will be the effect of this disaster, and which area will be how much the effect will be happen on some specific area. So all these things can be easily predicted by that uh, big data. Also, we can analyze the impact on economy of that disaster. So how to recover from that disaster. So all this analysis can be done efficiently with the big data. After some disaster management, how will we allocate the some resource allocate the resources? Before that, how the resources will be allocated? We have to move the people from some place to other place. All these things easily uh, uh, can be done by the analysis of the data, because we are having different data from the different reasons. The people living somewhere, we can easily identify, like, we have to move these people. How will we communicate on these days? So all these things can be easily done by big data, so it is very useful in disaster management also. So at the end, we can summarize by the comparison of big data versus small data. So big data is what we have talked about in this presentation. But small data is like, there's not any term like small data. We are having database management system, which we call traditional database management system or relational database management system. But as the data is growing and it is becoming very huge, and we is calling it as a big data, so the counterpart is normally we are calling it as a small data. Otherwise, there is not any term as small data. So we compare it. So we can say that in a small data, we are having structured data. It means we are having tables, we have rows and columns, and data is in proper format in a small data. But in big data, we have seen that the data is structured as well as semi-structured and mostly unstructured data, like images, videos, and likes in Facebook. This kind of data we are having in big data. Small data generally stores the data in KBs, MBs, GBs, and maximum in TBs generally. But in big data, it starts from the petabyte, exabyte. So the data volume is very high in big data. So small data increases gradually as we
What is the
talk.
value of that PB and EB, ma'am?
EB is exabyte. It is 10 to power 18 bytes. And TB is, I think, I'm not sure. Maybe it is 10 to power 15. Petabyte, I'm not exactly, I don't remember. But exabyte is 10 to power 18. So the small data is, as we talked, like it increases gradually. As we talked about a university system, the data increases very gradually. But in the big data, the data increases very rapidly with a high rate. So small data is centralized. For example, the server is there's one server only, and we keep the server in a premises itself. Like for the university, it will be on the university campus only. For the shopping mall, it will be on the shopping mall only. So it is a centralized database. There is only one server. But the big data is globally distributed. We are having multiple servers of the multiple servers and um, mm, multiple locations for the big data. So it is across the globe. Like on the different countries, we are having the server for the same data. We use softwares for small data like SQL Server, Oracle, and MS SQL. This kind of server we use for small data. But for big data, we use Hadoop, Spark, Cassandra. So these are different technologies. These are having different processing, storing method, and analyzing methods. So these are different from Oracle, SQL servers. So small data use a single node, but the big data uses like we create clusters of multi-node, and then we access the big data. So the how like from this we can understand, like in the today's life, how important is big data, and we really need to store our data in an efficient manner, so that we can easily identify the problems, and we can easily grow up with our business and with our processes. So yeah, that's it all about the big data. Yeah, thank you.
So I have one doubt.
Yes.
So, like we are saving our data in some cloud facility, like if we are using iPhone or MacBook and we are saving our data in iCloud,
Hmm.
is Apple taking any help of third party to save that data, like Hadoop or other third party companies?
Yeah, I means maybe Apple must be having some
Their
servers, cloud.
own
Yeah,
thing.
they have they can any case like they can they have, maybe they have purchased the servers, or they are having, they have taken from like Google, Amazon. So like I don't have stats, but there are only two methods. Either they can purchase it, or they can take from Google, Amazon. Like how the Google, Amazon, and this Microsoft works, they give the servers on rent. When you need it, you use it, and then you release it. So you pay for the timing when you are using the server only. So how the Apple is doing, like they have purchased the servers, or maybe they have like rented from these companies. There can be those two
Okay.
cases.
My thing doubt is like whenever you are taking, imagine I have a hospital, big hospital, and I want my data to be saved, and I'm taking help of any third party.
Hmm.
So I will have to trust them that my data will not be vulnerable.
No, so they will only give you the servers. They will give you the space, storage space. You if you are having hospital, you only will move the data to their servers. So now, if, for moving the data, you have to recruit some IT persons, or you have to take help from some other IT persons. Like they will not, like Google or Microsoft will not move your data. They will only give you the servers and the storage space. But they will
So
the
means
data will be.
accessibility is only to the user only. Means they
Yes.
are not accessing your data. They are just giving you a storage facility.
Yes, you will create your login IDs, password, all the authentication system. There are all services provided by them in which you can create advanced security on your data. Like you can create authentication system who can log into your data, who can see, even who can see like data is there. Otherwise, it is invisible to everyone. So these kind of tools they provide, but uh, giving access or anything like authorization, you will do that. They will not do anything. For example, like if bank is giving us the net banking facility, but it is us who are having login ID and password. Bank can't do login to our account, because we only know our login ID and password. In the same way, they are giving the storage and they are giving the servers, but if we are creating our authorization system, only we
So
can
it's like
access
a
that data.
automatic thing, like you said. When we are having a big task, they are dividing it into three tasks, and in server they are copying in two copies or multiple copies, depends. So
Hmm.
it's a automatic thing. Like whenever I am saving my data, it will divide in three part and it will save in copies. It's automatic process, or they will do it later.
No, no, it is not automatic process. Like first we need to analyze the data, like how we have like how much data are we having. Then how will we it, how efficient will it be? Like if I am having thousands of TB data, so how how many servers do I need? How I need to analyze. Like there are people who do this task only. Like they analyze the data. They predict that if we will divide it into 4 or 5 parts, it will work properly. Then we will try on these environments. Like if we have divided data into 4 parts, and when we will query it out and it is taking much time, then we will go further to divide it more. So it works in that way. It is continuous process.
Okay.
So like for it is like analyzing and trying, and then if we are getting a result as we want, then it is fine. Otherwise, we will go for improvement. There's not any specific method that if data is of 1000 TB, I need to cut it into 5 parts or 6 parts. I need to analyze what my business need, and how how, like, which type of query I am having. So accordingly, I will decide. But they will not do. Google, Microsoft will not do. I have to do that if I am taking the server from there from them.
Means they will provide the storage facility, but
Hmm.
to manage all these things, company appoint their own IT guys to handle this.
Yes, yes. Company is having own IT guys to handle that. They don't provide anything.
Okay.
Yes.
So how, ma'am, you are connected to this field?